In this video, we're going to describe some of the characteristics of waves. We'll start off by talking about amplitude. The amplitude of a wave is how high the wave is at a particular point. For example, let's look over here. At this point, the wave has an amplitude of 1.0. Well, over here, at this point, the wave has an amplitude of 0. You should note that places where the wave has an amplitude of 0 are called nodes. Okay, now I'm going to change the maximum amplitude of this wave to a value of 0.5. Notice that when I do this, the minimum amplitude immediately changes to negative 0.5. Now I'll just change the maximum to an amplitude of 1.5. Do you see the minimum amplitude is now negative 1.5? For the rest of this demonstration, I'll just set the maximum amplitude of this wave to 1.0. A region of maximum wave amplitude, such as what you see here, is called a crest. A region of minimum wave amplitude, like what you see here, is called a trough. Now we're ready to learn about wavelength. The wavelength of a wave is the distance from crest to crest, or trough to trough. It can also be measured as twice the distance from one node to another. Okay, let me change the wavelength of this wave and see if you can now tell me what the wavelength of this new wave is. Do you see that the distance from crest to crest goes from 0.25 meters to 1.25 meters? That tells me the wavelength of this wave is 1 meter. I can also see that the distance between two nodes is half a meter. Twice the distance of half a meter is 1 meter. So either way I look at this, I measured the wavelength of this particular wave as 1 meter. Now let's talk about frequency, which describes the time-dependent behavior of a wave. In the white box in the upper right-hand corner, there's a little timer that's going to represent our time in seconds. It won't exactly measure the time in seconds, but it'll give us an idea of what's going on. Now let's set the wave in motion. Notice that the wave changes its amplitude with time. I wonder how long it's going to take for the wave to return back to its original position. Almost there. There it is. It looks like it took 1 full second for the wave to go from where it started back to where it came. The frequency of a wave is the number of times a wave goes through 1 full cycle every second. In this case, it's pretty easy to figure out because we see that the wave went through 1 full cycle in 1 second. The unit that is used to measure frequency is called a Hertz. And a Hertz is the number of waves made per second. So in this case, the wave just has a frequency of 1 Hertz. Let's change the wavelength of the wave. And in this case, we see that the wavelength of the wave is a full 2 meters. I wonder how long it'll take this wave to go through 1 full cycle. And begin. Wow, in this case, we see it took a little longer. 1 full wave took a total of 2 seconds to go through a full cycle. Since 1 divided by 2 is a half, we would say that this particular wave has a frequency of 1/2 Hertz. Let me try changing the wavelength one more time. Can you tell me what the wavelength is in this case? If you said that the wavelength is half a meter, you're correct. We'll set our timer back to 0, and let's see how long it takes this particular wave to go through 1 full cycle. Wow, that didn't take very long at all. In this case, we see that 1 wave went through a full cycle in a half a second. 1 divided by a half is equal to 2. So this particular wave has a frequency of 2 Hertz, or 2 waves per second. Finally, let's go over how to calculate the speed of a wave. It's really quite simple. To find the speed of the wave, you simply take the wavelength of the wave and you multiply it by the frequency. Let's find the speed of this particular wave. I'm going to set the wavelength equal to 1/4 of a meter, and now let's find its frequency. Wow, that didn't take very long at all. Only 1/4 of a second. So we went through one full cycle in 0.25 seconds. That works out to 4 cycles per second, or 4 hertz. Now we can calculate the speed of the wave using the frequency, 4 hertz, times the wavelength, a quarter of a meter. Well, a hertz is the same thing as a second to the minus 1. So we can take our speed as 4 inverse seconds times a quarter of a meter. That comes out to 1 meter per second, and we've just calculated the speed of the wave. I hope this video helped you learn a little bit about the characteristics of waves. In conclusion, here are some key terms that you should know.